Hello everyone, myself Uma S, working as Assistant Professor, Department of ECE. Welcome to ACLIC Lab. Today's experiment is DSBSC Generation using balanced modulator. So DSBSC stands for double sideband suppressed carrier. So in amplitude modulation, we know that the amplitude modulated wave consists of three components. One is the carrier frequency component and the two sideband frequencies. One is the upper sideband frequency and the lower sideband frequency. The disadvantage in amplitude modulation technique is 2/3 of power is wasted because of the carrier frequency component. That is because carrier frequency component does not carry any information, but all the information is carried out by the two sidebands. In DSBSC relation technique, this disadvantage is overcome. So let us see DSBSC experiment. So in double sideband suppressed carrier, we will suppress the carrier signal in the modulated output so that the power is equally distributed between the two sidebands, so that it becomes the power efficient modulation technique compared to amplitude modulation technique. Whereas this DSBSC technique is nothing but one of the type of a amplitude modulation technique. Let us see the experiment. So this is the module for double sideband modulation and demodulation. So in this modulation kit, we have module to obtain the modulated output and a module to obtain the demodulated output. So here for this experiment, we are not using any external signal generator, as this module comes with the built-in signal generators. In this module, the upper one, this IC denotes the modulating signal and this part denotes the carrier signal generator. So here it is written that AF output. Here AF stands for audio frequency output. So from this part, modulating signal is generated, and from this part we will generate the carrier signal. So the wire from the AF output to the AF input of the modulator block, and then the carrier output to the RF input to the modulator block is connected. The one thing to be noticed is we can vary the amplitude of both the carrier signal as well as the modulating signal, but here the frequency is fixed for this module as the signal generator is built in. So once the signal is given to the modulator part, here we can see the output pin is here. From this we can see the modulated output. So from this, one of the wire is connected to the CRO probe. So from here we can see the modulated output. So this modulated output is connected back to the demodulator detector part as an input. This is the demodulator output part. So we know that the demodulated output part, the amplitude is reduced compared to the original message signal. So in order to amplify the signal, we are connecting back the demodulated output to the input of the amplifier just to enhance the amplitude of the signal. But the frequency of the demodulated signal must remain as same as the original signal. So let us turn it on. The connection has to be done as given in the manual. Let us turn it on. So after doing the connections, everything is done. Just turn on the power supply of the module. So this is our waveform for the DSBSC modulated wave and the demodulated wave. The waveform in the blue color denotes the modulated output. So the waveform almost resembles the waveform of the amplitude modulation. So here you can see the side bands. If I vary this time per division, it is clearly seen. The Vmax and the V minimum. In this experiment also, we have to calculate the modulation index. So in order to calculate the modulation index, we must note down the Vmax and V minimum from the CRO. So in the CRO, the maximum output voltage gives us the Vmax and the minimum output gives us the V minimum. So using the values from the CRO, we can calculate the modulation index, and we have to check the frequency of the demodulated signal must be same as the frequency of the original signal, that is the message signal. For that I will connect. this one, the below one is the input signal and the upper one is the output signal, that is a demodulated signal. So in this signal from here, this side, we can notice that frequency is almost similar. So our output frequency is around some 894 Hertz and the input is of around some 903 Hertz. Though it's not the exact frequency, but it's almost similar. So this is all about the conducting the experiment. Expected Viva questions for DSBSC experiment is, you must know what is DSBSC, advantages of DSBSC, applications of DSBSC, operation of balanced modulator, operation of the envelope detector, what are the disadvantages of amplitude modulation and how to overcome the disadvantage of amplitude modulation using DSBSC generation using balanced modulator. So these are some of the expected Viva questions. Thank you.